All right, guys, we are on the back side of day 6 notes, and number 3 says in the figure QS and QU are common tangents. Okay? They want you to find the measure of QS. So remember what we talked about on the front side, that two tangents to the same circle are equal. All right. So we know that QS has to be the same length as QU. Problem is we're missing this little segment here, RS. All right. But what we do have is if we only look at part of our picture, QR and QT are two tangents to that little circle, and they have to be equal. Okay. So we could tick mark them. And therefore 2y plus 9 has to equal 15. Okay. If we subtract 9, 2y comes out to equal 6. And divide by 2, y comes out to equal 3. All right. So now that we know that y is 3, we can substitute it in. 4y, or 4 times 3, this segment now becomes 12. Okay. If we substitute in here, 2 times 3 is 6. 6 plus 9, this segment comes out to be 15. Okay. And again, they want to know the whole length of our line segment here, QS. Okay. Well, QS is going to have the same length as QU, and if QU has a length of, 27? Then QS is also going to have a length of 27. And so now we can say QS equals 27. Okay. Number 4 says that the area of circle H is 100 pi, and HF is 26 centimeters. So H to F, that's 26. They want to know what's the perimeter of quadrilateral EFGH. EFGH. So this four-sided figure in here. Problem is we don't have any of the sides in this figure. We have one segment length in the middle, but that's not part of the perimeter. So we're going to have to use what they told us up here, which is 100 pi. That's the area of a circle. And so, the area of a circle is equal to pi r squared. We're going to take the area out and put in the 100 pi. And because both sides have pi, if I divide by them, they'll cancel, and I'm left with 100 equals r squared. And to get rid of the square, we're going to square root, so that r comes out to equal 10. And r is the radius, and we actually have two radii in here. One of our radiuses, or radii, is hg, and that length is going to be 10. Our other radius is he, and so that's also going to be 10, since all radii of a circle are equal. Okay. What we're going to notice next is that this is a right triangle here. Okay. You guys can see they put in that nice right angle for us. They didn't have to, because that's a tangent meeting a radius, and that's something we talked about, that has to be a right angle. Okay. So now we're going to go ahead and take Pythagorean theorem. And in that green triangle that I highlighted, 26 has to go in for the hypotenuse, because it's the side across from the right angle. And 10 can go in either for A or B. And we're going to go ahead and solve for that last side of that green right triangle. Okay. So we end up with 100 plus B squared equals 26 squared, which is 676. If we subtract 100, we'll get 576. And when we square root, we're going to test to see if it's perfect. If you type it in your calculator, it comes out to be 24. So it is a perfect square. And this side ends up being 24. And therefore, this other side is also a tangent, just like EF is. Right? And so this has to be 24, because two tangents drawn to the same circle, they have to be equal. All right. And now we have all four sides of our quadrilateral. And so we're going to go ahead and add them up. Our perimeter is going to be 10 plus 24 plus 24 plus 10. And so our perimeter comes out to equal 68. Okay. All right, next up, we're going to go ahead and talk about common tangents, okay, and the different situations we could have when we have a common tangent to two circles. Okay, so it's a line that is tangent to both of two circles. Okay, there are 5 different situations that occur, and this is a lot easier to see if we have a straight edge, although I don't have a straight edge tool on this applications. So I'm going to try my best straight lines that I can. Okay, but if you have a straight edge when you're doing these notes, I would recommend using your straight edge up to line up and then to draw your straight line or your tangent line. Okay, so two circles that do not intersect have a possibility of 4 common tangents. So the first common tangent that we could draw goes ahead and touches the tops of both circles. Okay. The second common tangent that we could draw touches the bottoms of both circles. Okay. The third common tangent that we could draw touches the insides of both circles at a diagonal. So for instance, that. And then the other one slants the other way. So this has a possibility of 4 common tangents. Okay? So 4 common tangents can be drawn if we have 2 circles that do not touch or intersect. All right, we're going to do these for the next 4 cases. So next up, we have 2 circles that when you push our last picture together would overlap. And we want to know how many common tangents we can draw. So we can still draw the one that goes across the tops of them. We can still draw the one that goes across the bottoms of them. But we can't draw the ones in the middle because remember, tangents aren't allowed inside the circle. They're only allowed to touch the outside of the circle once. And so you can see that this one, you can't draw the 2 diagonal ones like we did in the last picture. And so this one only has 2 common tangents. Picture number 3 are 2 circles that are internally tangent. Okay, so again, when we want to draw our common tangents, we have to touch both circles. So the only spot that we could touch both circles is where both circles touch. Okay, and so we can only draw that common tangent right there. That is the only line where you can just touch both circles. And so this only has 1 common tangent that can be drawn. Okay. Next picture. Okay, looks kind of similar to the first 2 there, but they're not overlapping and they're not touching. They're just touching at one point. So in this case, we can draw the one that goes across the top still. We could draw the one that goes across the bottom still. And in this case, we can draw one right through that point where they touch. And so in this case, we can draw 3 common tangents. Okay. In our last situation, we have 2 circles that are what they call concentric. They have the same center. Okay, almost like a bullseye or a target. In order to touch the inner circle, we would have to go through the outer circle, though. And so we know that tangents can't do that. They can't go through the circle in order to be tangent. So there is 0 common tangents that I can draw in this picture or situation. Okay. All right, let's take a look at what else they have. Number 5. It says 2 circles are externally tangent, meaning that the 2 circles, okay, like this picture up here, are touching because they're saying that they're tangent, but they're touching on the outsides, all right? So they are the little circle is not inside the bigger one, all right? So they're externally tangent. And it says that the lengths of their diameters are 4 and 6. And we want to find the length of the line segment joining the centers of the circle. So if I take the center of this circle and the center of this circle and I connect them, they want to know how long that is. Okay. So what we have to realize is this line segment right here is a radius of the big circle. And so we're going to look at the bigger number, which is 6. If the diameter of this big circle is 6, then the radius is 3. This line segment here that goes from the center to that point where the circles are touching, that's a radius of the little circle. And so we're going to look at the diameter that's 4 and know that the radius would be 2. And this is a radius. So that would be 2. And now I can tell you 3 plus 2 would have a length of 5. Okay. All right. Last question. Circle G has a center at 2, 5. So we've never graphed a circle, but we're going to start graphing circles. It's one of the last things we'll do in this unit. Okay. And so there's the center 2, 5, and it has a radius of 3. So what we do is we go up 3, put a point, down 3, put a point, right 3, and left 3, and we draw the best circle we can. That circle has a center at 2, 5 and a radius of 3. Okay, and this is circle G. Actually, I should have put When they call a circle G, technically that center point is known as G. Okay. And then it says circle H has a center at 2, 0. So 2, 0 would be here. And it says if the circles are tangent, meaning that the circles are touching, which line could be tangent to both circles? All right, so what we're going to do is, because these circles are tangent, meaning that they're touching, just like this question up here, then this circle must have a radius of 2. So I'm going to go ahead and draw in the radius of 2 so I can see what the circle would look like. And they're calling this circle H. Okay, so they want to know which line could be tangent to both circles. So first one up, x equals 2. X equals 2 is a vertical line, right? Think of Vux, V-U-X. X equals a number. Okay, so a vertical line at 2 would go right through the circles, meaning that that is not tangent if it goes through the circles. So I'm going to get rid of that. Okay, it can't be it. X equals 0 is also a vertical line, except it's at 0. All right, and so it would be tracing over the y-axis, and you guys can see as I trace over the y-axis, I entered through circle G, or the red one, so this can't be tangent. So we're going to check these ones. These ones, guys, are y equals a number, so these are horizontal lines. So a horizontal line at 2 would look something like this, and that green line only touches the blue circle and only touches the red circle at one point, so I'm going to say that this is probably my guess. All right, but choice 4 says y equals 5. 2, 3, 4, 5. So another horizontal line, and you guys can see that line goes through the red circle, and so through the red circle means that it's not tangent to it, and so we're going to get rid of that choice and go back with y equals 2 is our answer. All right, guys, I will see you on the next day of notes.